The diagram on the screen over there illustrates the chemical content of a nickel cadmium alkaline battery. The electrolyte is potassium hydroxide, and the positive plates are made of nickel hydroxide, and the negative plate is cadmium. So as you can see, this is just technically another case of two dissimilar metals immersed in an electrolyte. There is a potential difference which is built up there, a potential difference which is built up between those plates, and because they are immersed in a common electrolyte. So it's an electrolytic cell, which is a secondary cell, which is rechargeable. It's also one type of cell that you will find on an electric vehicle. And we also have lithium ion cells. They have an energy density of up to 140 watt hours per kilogram. That is the power to weight ratio of the lithium ion battery. It works as follows. The negative pole and the positive pole are part of the individual cells of a lithium ion battery, together the electrolyte and separator. The anode is a graphite structure and the cathode is a layered metal oxide material. When the battery is charging, the lithium ions move from the anode to the cathode and take electrons. The number 4 ions determines the energy density. When the battery is discharging, the lithium ion releases the electrons to the anode and move back to the cathode. Useful work is performed when electrons flow through the closed external circuit. Okay, if you check, in order to summarize, the lithium ion battery, we have graphite in the positive, that is the cathode, and we have the structure of the lithium ion battery is as shown there. The positive is made of lithium metal oxides. The negative is seen to be made of graphite, and we have a separator in between in order to prevent discharge of the cell internally and loss of charge. During charge, lithium ions migrate towards the negative electrode and store electrons from an external energy source. So the lithium ions are stored in the negative electrode, which is the graphite. Then during discharge, lithium loses electrons to the negative electrode, and these electrons drive an external load. So the lithium loses the electrons through an external load, and in the process, an external load is supplied with what? With current. So you see, the basic principle still applies again. In a lithium ion battery, those are two metals which are different chemically, which are then immersed in an electrolyte. In the case of a lithium ion battery, we are not told the type of electrolyte that's used there, because it's a complex mixture of so many chemicals which are known to be very poisonous, very toxic, and it is an important precaution that should be observed when working with these batteries to make sure that we don't come in contact with the electrolyte. Also, do not allow any leakages of this electrolyte, because it can lead to overheating of the lithium ion battery. We call it thermal overrun, and the end result of this thermal overrun can be explosion of the battery itself. And the lithium ion battery shouldn't allow the leakage of, say, for example, salt water, seawater into the lithium ion battery. It will immediately explode, and the explosion will release a mushroom type flame, like it was an atomic bomb or something. It's quite dangerous when it explodes.